This is test 3. Test 3 contains 9 problems, and we are going to solve each of the problem. The first problem say, derive a formula for the derivative of the inverse tangent function. The inverse tangent function of arctangent is a function whose derivative is not a trigonometric function. It doesn't happen like sine or cosine of x, whose derivative, the derivative of sine of x is cosine of x, the derivative of cosine of x is minus sine of x. The derivative of arctangent of x is not a trigonometric function. So how can we do this derivative knowing that the derivative respect to the x of tangent of x, knowing these facts, that the derivative respect to the x of tangent of x is equal 1 cosine square of x, or knowing that the derivative respect to y of tangent of y equal 1 divided by cosine square of y. How, using this fact, we can find the derivative of arctangent of x? First things, the first step is takes the inverse function of arctangent of x. What is the inverse function of tangent of x? Is the of arctangent of x is tangent of. So take the inverse function of tangent of y equal the tangent of the arctangent of x. And now the tangent of the arctangent of x is x, because the tangent and the arctangent, they are inverse function. Arctangent of x produce a y, and tangent of y produce the x. So they are inverse function. So the equation that I have is tangent of y equal x. So the derivative respect to x of tangent of y is the derivative respect to the x of x. What is the derivative respect to the x of the function x? 1. Is the slope is 1. What is the derivative of tangent of y? Is 1 divided by cosine square of y by the derivative of y respect to the x. Now I have the derivative of y respect to the x equal 1 multiplied by cosine square of y. And this is the derivative of y. Of y, who is y? Y is arctangent of x. So I'm finding the derivative of arctangent of x. But I cannot leave the problem like this. I need to put it in in terms of the variable x. So I need to do something else. So we do the triangle that we have learned in class. This is the triangle. This is the angle y. It's a rectangle triangle. This is the angle y. And tangent of y is x. So tangent of y is x divided by the adjacent. So it's x divided by 1. So tangent of y is x divided by 1. So the hypotenuse is a square root of x squared plus 1. What is cosine of y? Now I can see what is cosine of y. Cosine of y is the adjacent divided by the hypotenuse. And now I can have the final result. The derivative of y respect to the x is 1 multiplied by 1 square root of x squared plus 1 cosine square. So the derivative of y respect to the x is the derivative respect to the x of arctangent of x is equal 1 divided by, what is the square root of the, what is the square root? A square is x squared plus 1. we can x squared plus 1, sorry. So we can evaluate this derivative to see if this formula for the derivative of arctangent of x makes sense. Let's go to do this. Tangent of x is a function. This is pi divided by 2 minus pi divided by 2, and tangent of x is a beautiful function that does like this. Does like this and goes to the infinity when x approaches to pi divided by 2. Arctangent of x is the inverse function, and the inverse function means that the point pi divided by 2 comma infinity is the point infinity comma pi divided by 2. So the arctangent of x is a function who do minus pi divided by 2 who do like this. This is arctangent of x. Arctangent of x is this function. And the slope at x equals 0 of arctangent of x, the slope looks to be like 1, more or less is 1. What is the slope here at x equals 0? The slope at x equals 0 is 1 divided by 0 squared plus 1, or 1 divided by 1. What is the slope at x equals 10? The slope is smaller. So the slope at x equals 10 will be 1 divided by 10 squared plus 1, or is 1 divided by 101, a smaller slope. So as you approach to the infinity, the slope becomes 0, or horizontal slope. So you can check this equation. Let's go to the next problem. This problem is solving a linear differential equation. A linear differential equation is of the form d dy ddx plus p of x by y equal q of x. So the first thing is to put this equation that they give us in this form. So if I divide d dy by ddx on this equation, on here, I will have d dy divided by ddx equal y minus 1 sine of x. Okay, so sine of x is what multiplied to the x. So let me put it in the standard form, d dy ddx minus sine x by y equal minus sine x. And now I can identify the q of x with the q of x. The p of x is minus sine of x. And what is the integrating factor? The integrating factor of this linear differential equation is e to the integral of p of x ddx. What is e to the integral of minus sine of x ddx? What is this integral? The integral of sine of x is cosine of x, so it will be e to the cosine of x, because cosine of x, the derivative of cosine of x is minus sine of x. So I found the integrating factor. The integrating factor makes the magic that when I multiply the differential equation by e cosine of x by the derivative of y respect to the x minus e cosine of x by sine of x by y equal minus e cosine of x sine of x. So the integrating factor makes the magic that now the left side of the equation can be written like this: the derivative respect to the x of the product e cosine of x by y. If you make the derivative of this product, you will find this. Okay, so this is equal e minus e cosine of x sine of x. And now what is left, we integrate both sides of the equation. If we integrate both sides of the equation, we will have e cosine of x by y equal minus the integral of e cosine of x sine of x plus c. And now I have to make this integral. What is the integral of e cosine of x sine of x? Is e cosine of x. Is e cosine of x. Why? Because the derivative of e cosine of x will be e cosine of x by the derivative of cosine of x, which is minus sine of x. So the equation will read like this. Plus c e cosine of x by y. So y of x will be e cosine of x plus c divided by e cosine of x e cosine of x. Now I can write the equation like this. Y of x equal 1 plus c e minus cosine of x. And this is the solution to the differential equation. And the problem is done. Let's go to the next problem. This problem is about solving this integral from 0 to a square root of 3 divided by 2. The function is x squared, and in the denominator there is the square root of 1 minus x squared cubed. As we have learned, wherever it appears 1 minus x squared, or a square root of a squared minus x squared, in this case the a is 1, the substitution that we use is x equal a sine of theta. Because a is equal 1 in our case, so the substitution that we are going to use is x equals sine theta. So if x is equal sine theta, v dx is cosine of theta d theta. The derivative of the sine is the cosine. So the integral have several limit of integration. When x equals 0, sine of theta is 0, so this means that theta should be 0. And when x is equal to a square root of 3 divided by 2, sine of theta is a square root of 3 divided by 2, so theta 60 degrees or pi divided by 3. So we know what are the limit of integration if we make the change of variable x equals sine of theta. So let's go to do the integral. The integral from 0 to a square root of 3 divided by 2 of x squared divided by 1 minus x squared 3 half d dx is equal to the integral from, we are going to make the change x equals sine of theta. So in the numerator will appear sine squared of theta. In the denominator will appear 1 minus sine squared of theta 3 half. And the d dx is cosine of theta d theta. And the limit of integration is from theta equals 0 to theta equal pi divided by 3. Perfect. Now we remember the fundamental trigonometric identity that says that 1 minus cosine square of theta is 1 minus sine square of theta is cosine square of theta. So the integral will be sine square of theta divided by cosine square of theta 3/2 by d d theta cosine of theta d d theta. So the integral will be from theta equals 0 to theta equal pi divided by 3 sine square of theta divided by cosine square of theta. The square will cancel with these two and will be cosine cube of theta multiplied by cosine of theta d d theta. So the integral will be the integral from theta equals 0 to theta equal pi divided by 3 of sine square of theta divided by cosine square of theta d d theta, or it will be the integral of tangent square of theta d d theta, or it will be equal to the integral of sine square of theta divided by cosine square of theta d d theta, or it will be equal to the integral. I can write again the fundamental trigonometry identity that say that sine square of theta plus cosine square of theta is equal 1. So this will be 1 minus cosine of square of theta in the numerator multiplied by cosine square of theta d d theta. And now the integral is the integral of 1 divided by cosine square of theta minus 1 d d theta. And what will be this integral? It will be the integral of 1 cosine square of theta d d theta minus the integral of d d theta. And the interval of integration, we know it's from theta equals 0 to theta, I think is pi divided by 3. What is the antiderivative of cos 1 divided by cosine square of theta? The antiderivative of cosine of 1 divided by cosine square of theta is the function whose derivative is 1 divided by cosine square of theta. Which one is the function whose derivative is 1 divided by cosine of theta? Tangent theta. So tangent theta minus the integral of d d theta, which is theta. So now we have to evaluate between 0 and pi divided by 3. If we evaluate, the answer will be tangent pi divided by 3 minus pi divided by 3. This is the evaluation at pi equals 3 minus tangent of 0, 0, minus 0, 0. So this is the result. Let's go to the next problem. Determine whether the improper integral, the integral from 0 to infinity of the function 1 divided by square root of x multiplied by x plus 1 converge or diverge. So remember that when we have improper integral, the problem that we have is that we cannot use the fundamental theorem of calculus. When the interval AB, when the interval is infinity, we need to reaccommodate things. And when the function in the interval AB is not continuous like this one, because as you see, when x tends to 0, when x equals 0, the function is not defined. So we need to do this integral in two parts. So what are the parts that we have to do? Imagine that the function is something like this, whatever it is something like this, whatever it is. So let's go to put an intermediate point, the 1 maybe. So this is the 0, and this is the V, and this is the C, the point C. So I'm going to do the integral in two parts. In the first part, I'm going to measure this area, and I'm going to make V to go to 0 plus. In the other integral, I'm going to measure this area, and I'm going to make the C to go to the infinity. So the limit. This has to be done in this way because the function on the interval 0 infinity at 0 is not defined. Is not even defined, so I need to approach to the 0 to see what happens. And at the infinity, the interval 0 infinity is an infinity interval, but the theorem of the first fundamental theorem of calculus is made for intervals AB that are not infinity. So, how we will put this integral? The integral from 0 to infinity of 1 divided by square root of x plus 1 ddx will be equal to the limit when v goes to 0 plus of the integral from v to 1. 1 or 2, it doesn't matter what number you, of the function 1 divided by the square root of x multiplied by x plus 1 ddx plus the limit when z goes to infinity. So I will cover the second area, this area, the blue one, of the integral from 1 to z of what? Of the function 1 divided by square root of x plus 1 ddx. Okay, these are the two limits. To find this integral, we did it at class, and I think that we do the change of variable u equal square root of x. So doing this change of variable, we find that this integral indeed is an arctangent, if I remember. Let's go to do it. Let me put it white. So we do u, let's go to do now this integral. The integral from a to v of 1 divided by the square root of x plus 1 ddx. So we say the change of variable is u. So u is equal to square root of x 1/2. So v du ddx is ddx is 1/2 x minus 1/2. Or du ddx is 1/2 1 divided by x 1/2, or 1/2 1 divided by the square root of x. So 1 divided by the square root of x by ddx is 2 times ddu. But this is sitting down here. 1 square root of x ddx is sitting down here, so this is 2 times ddu. So now, because I have this change of variable, u equal square root of x, u is equal square root of x, so u squared is equal x, so x plus 1 is u squared plus 1, obviously. So now I have all the pieces to do the integral. The integral from a to v of 1 divided by the square root of x plus 1 ddx equal the integral from a to v. Well, it will change the limit of integration. So let's go to do the indefinite integral. Okay. So it will be 1 divided by square root of x ddx, 1 divided by the square root of x ddx, 1 divided by square root ddx. This is 2 times ddu, so it will be 2 times ddu divided by x plus 1, but x plus 1 is u squared plus 1, so this will be 2 times arc tangent of u. So the problem is almost done. So 2 times arc tangent of u, but u is square root of x, so it's 2 times arc tangent of a square root of x. Now let's go to this part. Let's go to this part here. Let's go to make this limit, knowing that the integral of this expression is 2 times arctangent of a square root of x. So I think we did it in class, we did it at quiz, and you can find the solution, and you can find that the integral converge, and this one also converge. And if I don't, okay, you do it. Well, let's go to do it. So it will be, let me do it. It will be the limit when v goes to 0 plus of, I'm looking here, of this integral. This integral is 2 times arctangent of a square root of x. And I have to evaluate between v and 1 plus the limit when c goes to infinity. I'm looking here of this integral. The integral is 2 times arctangent of a square root of x. And I have to evaluate this between 1 and c, and takes the limit when c goes to infinity. Okay, let's go to do it. So it will be the limit when v goes to 0 plus of 2 times. Let's go to put the 2 outside, the 2, because they have a 2 here and a 2 here, okay, and a 2 here, so I can put it. Arctangent of a square root of 1 minus arctangent of a square root of b. So this limit will be okay, plus the limit when c goes to infinity. The 2, I put it outside, the 2 is here, the 2, okay, of arctangent of c, arctangent of a square root of c minus arctangent of a square root of 1. Perfect. So this arctangent minus arctangent square root of 1 minus arctangent square root of 1 will cancel with this, positive and negative. Okay. So what is the limit of arctangent of b when v goes to 0? When v goes to 0, arctangent of v, let's go to draw arctangent, the function arctangent. Arctangent does like this. Pi divided by 2 minus pi divided by 2 plus pi divided by 2. When b goes to 0, arctangent goes to 0. And when c goes to infinity, arctangent goes to pi divided by 2. So the limit will be 2 times arctangent of 0 plus 0 positive will go to 0, and this will go to pi divided by 2. Pi divided by 2, so the sum, the product, it will be pi. So because pi converge, because the integral converge, this integral converge, okay, is finite, and the problem is done. Now let's go to do this problem, that is find the sum of the convergent series. It says that it converge. Why it converge? Because it's a geometric series, and the r is 3/4, that is less than 1. This is why it converges. Always that you have a series is very good to write. It's a good idea to write all the terms. So it's 3, 4 square plus 3, 4 cube plus 3, 4, 4, etc., etc. So if you sum to the infinity, what will be the sum? Well, to do this sum, first of all, we realize that the term that I have to multiply this term, if I multiply by 3, 4, I will obtain this term. If I multiply this term by 3, 4, I will obtain the next term. So this is really a geometric series, because this is the pattern that a geometric series. You multiply by a constant factor 3, 4, the previous term, and you obtain the next term. So let's go to make the sum. The sum of n terms will be 3, 4 square plus 3, 4 cube plus 3, 4. Now, will I write n here? You know, the first term is this one. So I have to write n minus 1. Because if the first term is this one, the second term is this one, so the n term will be n minus 1. So how I will do this sum? How we do the sum of the geometric series? We multiply this sum by the r. R by a sub n will be, if I multiply by 3, 4, the previous equation, this equation, what I will have? I will have 3, 4 cube plus 3, 4, 4 plus 3, 4 n instead of n minus 1. It will be 3, 4 n minus 1 here. Now I will subtract the first equation to the second equation. I will do a sub n minus 3, 4 a sub n. If I subtract the first equation from the second equation, I see the cancellation. This one will cancel with this one. This one will cancel with this one. This one will cancel with this one. And the term that will survive is the first 3, 4 square minus the last 3, 4 n. Okay, so a sub n that multiply 1 minus 3, 4 is 3, 4 square minus 3, 4 n. Now a sub n will be equal 3, 4 square minus 3, 4 to the n divided by 1 minus 3, 4. 1 minus 3, 4 is the same that 4, 4 minus 3, 4. So a sub n will be 3, 4 square divided by 1 minus 3, 4, which is 1, 4, minus 3, 4 n divided by 1 minus 3, 4 is 1, 4. Now, when n goes to infinity, s is the limit when n goes to infinity of a sub n. When n goes to infinity, if this number is less than 1, a number less than 1 raised to the infinity goes to 0. So in the limit, this term will disappear, so the sum will be 4 times 3, 4 squared, or 4 times 9 divided by 4 squared, or 9 divided by 4. And this is the sum of the geometric series. Let's go to the next problem. Let's go to do this problem. This problem says if determine the convergence or divergence of this series. This series is always to write the terms when n equal 2 is 2 natural log of 2 squared, plus when n equal 3 is 3 natural log of 3 squared. When n equal 4 is 4 natural log of 4 squared. It converge the sum or diverge. It's difficult to say unless we use a test. If we try to use the ratio test, the limit when n goes to infinity of a sub n plus 1 divided by a sub n, we will see that this limit is 1, so the test is inconclusive. You may use the test for the limit comparison test, but you don't know to which one you will compare. So the solution to this problem is to realize that the function f of x equal 1 divided by x natural log of x squared is first a decreasing function, is second is positive, and third is continuous. Then you can apply the integral test, and the integral test say that if the integral converge, the series converge. So the series goes hand by hand with the integral. So we have to see if the integral from 2 to infinity, from x equal 2 to infinity, of 1 divided by x natural log of x squared ddx, it will converge or it will diverge. So this is the limit when v goes to infinity of the integral from 2 to v of 1 divided by x natural log of x squared ddx. How we will do this integral? Well, maybe we make a change of variable and we name u as a natural log of x, because the derivative of u respect to the x, or ddu, is 1 divided by x ddx. And 1 divided by x ddx is sitting down here. So the integral will be equal to the integral from x equal 2 to x equal infinity. From when x is equal to, u is natural log of 2. To b, when x equal v, u is natural log of b. And we need to find the limit when v goes to infinity of what integral? Of 1 divided by x ddx. 1 divided by x ddx is ddu. Of ddu divided by u squared. And so this is from u equal natural log of 2 to u. Okay, let's go to do this integral. Is quite easy. Is the limit when v goes to infinity of 1 divided by u squared is u minus 2 plus 1 divided minus 2 plus 1. So is the limit when v goes to infinity, minus 2 plus 1 is minus 1, so it's minus u minus 2 plus 1 is u minus 1, or 1 divided by u, evaluate between natural log of 2 and b. So this will be the limit when v goes to infinity of minus 1 divided by v minus 1 divided by natural log of 2. So when v goes to infinity, this goes to 0, and so the limit when v goes to infinity is plus 1 divided by natural log of 2. So because the integral converge, write down, because the integral converge, the series converge, and the problem is done. Let's go to do the next problem. This problem says determine the convergence or divergence of the series. The series, the a sub n is 2n divided by 3n minus 1. How we determine the divergence? By the divergence test. What the divergence test say? It say that if the limit when n goes to infinity of a sub n doesn't go to 0, then the series diverge. So let's go to find the limit. The limit when n goes to infinity, when n goes to infinity of 2n divided by 3n minus 1 is equal to the limit when n goes to infinity, we divide by n the numerator and we divide by n the denominator. When n goes to infinity, this is 2 divided by 3 minus 0, or 2/3. So the limit is not 0. So if the limit is not 0, you are adding always to the series terms that are not going to 0, so the series will diverge. So this series will diverge because the divergence test say that if the limit of a sub n is not 0, is different than 0, and the series will diverge. So this series will diverge. Let's go to the next one. Okay, the next problem is determine whether the series minus 1 to the n divided by n cubed minus 5 converge conditionally or absolutely or diverge. Okay, as I say, it's always good to write a few terms of the series. So the first term will be with n equals 3, will be 3 divided by 3 cubed minus 5 plus, let's go to see the series with the absolute value. So it will be plus 4 divided by 4 cubed minus 5 plus 5 divided by 5 cubed minus 5, etc. plus 6. This is the series of the absolute value. 6 cubed minus 6. So the series with the absolute value will converge or will diverge. So the series with the absolute value is the series a sub n equal n divided by n cubed minus 5. I may try to compare with the series 1 divided by n squared, that is a p-series that converge. I will do the limit comparison test. The limit comparison test said if this is v sub n, if this converge and you make the limit when n goes to infinity of a sub n divided by v sub n, and this is a finite number, then if it's a finite number, this limit, then the comparison test say that if b sub n converge, a sub n converge. Same thing if you do it with a divergent series for b sub n. The result has to be a finite number. So let's go to see if this series converges or diverge. So if the limit is a finite number, converge. So a sub n, let's say that n divided by n cubed minus 5 divide by b sub n, 1 divided by n squared. Or what is the same, n divided by n cubed minus 5 multiplied by n squared. Or what is the same is the limit when n goes to infinity of n cubed divided by n cubed minus 5. And this limit, it will be a finite number. Well, we divide by n cubed. It will be the limit when n goes to infinity of n cubed divided by n cubed divided by n cubed. We divide by n cubed numerator and denominator. So this will be equal to 1. When n goes to infinity, this goes to 1. Divided by 1 minus 0, because when n goes to infinity, 5 divided by n cubed goes to 0. So the limit is 1. But the limit have to be finite. If the limit is finite, the structure of the series that I have compared, this converge, then this one converge, because the limit is finite. So if the series of the absolute values converge, the alternative series will also converge. Let's go to the next problem. This problem is, determine the converge or the convergence or divergence of the series. Well, very difficult to know. Let's go to write a few terms. 171 divided by 1 plus 2 7 squared 2 factorial plus 3 7 cubed divided by 3 factorial plus 4 7 4 divided by 4 factorial will converge, will diverge. Well, we need to use a test, and the test, when it appears factorials, the best test is the ratio test. The ratio test say if you find the limit of when n goes to infinity of a sub n plus 1 divided by a sub n, and this goes less than 1, then converge. It goes bigger than 1, diverge. It goes equal 1, inconclusive. So let's go to see in what case we are. So the limit, so a sub n is n 7 to the n divided by n factorial. And a sub n plus 1 is you make the change of n by n plus 1, 7n plus 1 divided by n plus 1 factorial. So let's go to make the limit. The limit with n goes to infinity. I don't need to put the bar for the absolute value because they are all positive numbers. So it will be a sub n is n plus 1 multiplied by 7n plus 1 divided by n plus 1 factorial. Divide by a sub n, 7n, n factorial. But this division is the same division if I flip the numerator with the denominator. So it will be it will be flipping here, multiply. I flip the division by a multiplication, and I flip the denominator to the numerator, and now I have to find this limit. So this limit is equal to the limit when s goes to infinity of n plus 1 divided by n, okay, or let's go to write it like the n plus 1, 7 to the m multiplied by 7, this is 7 raised to the power n plus 1, n factorial divide n plus 1 by n factorial. N plus 1 by n factorial is n plus 1 factorial. Multiply by n, 7n. So now it appeared the cancellation. 7n, 7n. N factorial, n factorial. So it will be the limit when n goes to infinity of n plus 1 and n plus 1, okay? N plus 1 and n plus 1. So it's the limit of 7 divided by n, and the limit when n goes to infinity of 7 divided by n, this goes to 0. But 0 is less than 1. So converge. And the problem is solved.